Okay, this is just a short video going through the exercises in SPSS. And so some of you did okay, but some people struggled a little bit, so I thought I'd create a few videos. Okay, so exercise one. This was the kind of the chi-square test. And what we're doing is we're looking if there's an association between gender and whether somebody survives. So it's a little bit like what was in the slides and we did in class between the class of cabin and survival. So let's just do analyze, descriptive statistics, and then crosstabs. So crosstabs does any sort of association analysis. And in the rows, we're going to have, here we just call this sex, which is gender, and survived. Whoops. And then we're going to click statistics, and we're going to have the chi-squared, and we're going to have the phi and Kramer's V, as we did in class. And we're going to have the clustered bar charts. Okay. So in the summary, I asked you, is there evidence for association? Now, the chi-squared test, we're not going to worry about the Fisher's exact test for the moment. This is calculating probabilities exactly. So we just do the Pearson chi-squared test. You always want, there's only one significant value for chi-squared, and this is the asymptotic significance two-sided. And the p-value is less than 0.01, so yes, there is evidence of association. And the p-value is less than 0.01. And just as an aside, you can see here that I told you in class that the phi was 0.1 was small, 0.3 medium, 0.5 large. So there is this kind of strong association there. And if you just look again, without doing any statistics, you can see, the majority of males did not survive, and the majority of females did survive. I.e., the females were the first to the kind of had the first go at the lifeboats, and most of the males who survived were people who were actually rowing the lifeboats. And I think we joked in class that this might not actually be the same if the Titanic disaster occurred today. Okay, so moving on to exercise 2, and this was on the bank data set. So we actually had to load this in manually. So file, open data, and we're looking for Excel data files. SPSS can load in a range of different data, not just SPSS files. So we've got bank data. So we just click open, and then we keep all the default options. And this is interesting because it's going to look a little bit like your project data sets in that you're going to have some kind of quantitative variables and you're going to have some like qualitative variables. Um, and the idea was just to give you a few different tests, just examining this sort of data set. So the first one is I want to see, we found that this is a Portuguese bank marketing data set. And we want to find out, is the average age different from the average age in Portugal, which is 43.9 years. So we want to see, you know, maybe if our average age is much older, we need to focus on, marketing to younger consumers. So a one sample t-test, this is 2A on the exercise. We're going to analyze, compare means, one sample t-test, and we have age, and we're going to test it against 43.9. We're not going to do effect sizes, just we don't want to complicate things, just the base option. Now, a mistake a few people make is they put the test value as 0. A one group hypothesis testing, we're always testing it against a hypothesized mean value. So click OK. And exercise 2A, what is the actual average age in the sample in the data set? This is 41.17 years. And we're just in this class focusing on two-tailed tests. The p-value is less than 0.001, so there is evidence of significant difference from 43.9 years. Okay, so the exercise 2B, what we're going to be doing is we're going to be comparing different bank balances for consumers with housing loans and without housing loans. And we could kind of think beforehand that consumers with housing loans are having to pay off their house each month. They're probably going to be a little bit poorer than consumers without housing loans. Well, let's just see if this pans out. So we're going to analyze. We want to do here, 2B was an independent samples t-test. So we're going to do compare means. independent samples t-test. The test variable is the balance, okay, which was this one here. And the grouping variable is housing. Now, as per the example in the class, we need to define the groups. Here, the housing, it's all no or yes in lowercase letters. So we have to put in manually the two values that are available. So here it's no or yes. We're not going to estimate effect size. Everything else is going to be default options. And we're going to click OK. So the first thing is we've got to do the Levene's test. The Levene's test, you remember the null hypothesis was that we can assume equal variances, and the alternative hypothesis is that the variances are not equal. The p-value is less than 0.001, so we reject the null hypothesis and we assume the variances are not equal. So it's like a two-stage test. We do Levene's test. If the p-value in Levene's test is less than our alpha, say 0.05, then we use the bottom row for the t-test. If the p-value for the Levene's test is greater or equal to our alpha, then we can assume equal variances and we do the top row. So let's just go through the results for 2B. What's the average balances for customers with no housing loan? Well, that's $1,595.28. The average balance for customers with a housing loan, $1,290.31. And is there a difference in balance between the two groups using alpha equals 0.05? Remember, we rejected on the Levene's test, so we're using the bottom row. Using the two-sided p-test, our p-value is 0.001. So that's enough evidence to reject H0. So there is some evidence of difference between the balance for people without and people with housing loans. Okay, so moving on to exercise 2C. We want to know, is there a significant difference between the balance for education levels, the different education levels? So again, we have these different education levels, primary, secondary, tertiary. And what we want to do is we want to do a one-way ANOVA. So we're going to analyze. And we're going to do that. And again, this is exactly as per in the slide examples. We're going to do univariate. Our dependent variable is going to be balance. Our fixed factor is education levels. The nice thing for this is that we don't actually have to kind of put in the education levels manually like we did with the t-test. Now, we're going to do plots. And literally, we're just going to have a horizontal axis education. Again, exactly like I did in class. We're going to add this. So we're now going to plot the means for each level of education. And we're going to do a post hoc test. And we only have one possible thing we can do it for, education. And we're going to do our default BOM. We're going to do the Bonferroni test again, exactly as we did in the slides. I'm going to click OK. Okay, so the overall ANOVA, as I said, we're only going to do in this class, I've kept it simple with one-way ANOVAs. This is the first ANOVA you do in business stats. And we can either use, because we only have one factor, so the overall model is the same as the single factor model, so we can either use the education row or we can use the corrected model row. So again, you can either use the top row, or probably better, you actually use the factor you want. The factor is education, so we use the row for that. So we look at the p-value. P-value is less than 0.01. So there's evidence that at least two of the means for the different education levels are different. And in fact, we can look here and we can see that people actually with secondary education have the lowest marginal means. Then people with only primary education, I guess it might be these must be older people. I mean, this is European country, so I would think that younger people all going to have pretty much good education levels. And we have people with tertiary education have much better balances, people who are university educated. And then we also have a few people unknown. It's almost, we can ignore that. That's almost like a missing value. And so the significance, let's just go through again. Is there significant difference? Yes, there is. The p-value is less than 0.01. And I ask you, Bonferroni test, which kind of education levels are significant using alpha equals 0.05? And again, there's only one p-value less than 0.05, and this is secondary tertiary and tertiary secondary. So this is the pair you have to write out. Those are the only two significant factor levels. And you can see here, let's just look. Secondary and tertiary, they have the biggest difference, and that's just about enough to give a significant difference between these. Okay, so again, this video is intended to be used in conjunction with the practical exercise if you wanted to review it, and also the slides for the week 11 class.